Okay, so a couple more examples of calculating confidence intervals. To estimate the mean age of students at a college, a random sample of 40 students is taken, and their mean age is 20.8 years. It is known from previous studies that sigma equals 2.3 years. Find the 95% confidence interval for the population mean. Okay, so we need to know four things. We need to know the sample mean. We need to know the population standard deviation. We need to know the sample size. And if we're letting our calculator do the work, we just need to tell it the confidence level that we want. If we're doing it ourselves using the formula, we need to know what number to put in for z sub alpha over 2, and that's going to depend on the confidence level. So here's our four numbers. X bar, the sample mean, is 20.8. So that's the mean age of the students in the sample. Sigma is 2.3. That's the population standard deviation. N is 40. That's the sample size. That's how many students are in the sample. By the way, N should always be a whole number. If the number you're putting in for N is not a whole number, something's wrong somewhere. You probably got them mixed up somehow. And since we're doing a 95% confidence interval, the number that we will be using for z sub alpha over 2 is 1.96. So here's what it looks like when we put those numbers into the formula. We go x bar minus z sub alpha over 2 times sigma over the square root of n, so that's 20.8 minus 1.96 times 2.3 over the square root of 40 is less than mu, is less than, this should be a plus, because this is the same thing but with a plus. So I fixed that. Now let's put this into the calculator. 20.8 minus 1.96 times 2.3 divided by the square root of 40 comes out as 20.087 something. And let's give that to one digit after the decimal point, round it to the nearest tenth. It would be 20.1. And then the exact same thing, but with a plus instead of a minus. So 20.8 plus all that other stuff is about 21.5. So 20.1 is less than mu, is less than 21.5. In other words, the population mean, the mean age of all the students at this college, is somewhere between 20.1 years old and 21.5 years old. Or at least, we're not absolutely sure about that, but we are 95% sure. And next example, noise levels at various urban hospitals were measured in decibels. The mean of the noise levels in 84 corridors was 61.2 decibels, and the standard deviation of the population was 7.9. Find the 95% confidence interval of the true mean. So x bar, the sample mean, is 61.2. The mean of the noise levels was 61.2 decibels. The standard deviation was 7.9. In the sample size is 84. Notice it's a whole number. And for a 95% confidence interval, z sub alpha over 2 is 1.96. So we put all that into the formula, and again, I forgot to make this a plus. You'd think I'd learn, wouldn't you? By now, So I've got this right here, and now when we put this into the calculator, and be a good idea if you try this yourself. Try putting this into your calculator and make sure the numbers you get match what I get, which is 59.5 to 62.9. The one with the minus gives me 59.5 when I round it to one decimal place. and the one with the plus gives me 62.9. Notice that our sample mean of 61.2 is right in between those two numbers. The interval goes from 61.2 minus the margin of error to 61.2 plus that same margin of error. Now we've still got to talk about sample size. How big does a sample have to be? But you know what? I'm going to make this a separate video just to kind of keep the topics separate. So in a separate video, I'll come back and talk about how we decide or determine how many pink elephants or flowers or hospital corridors or whatever we need to include in our sample.